Okay, so if you'd like to, it's loud. If you're here for the Lava packaging talk, you're very welcome to come forward. And let's get these up. Okay, so deployment tool is dead and packaging is the new solution we've finally got in for the production releases and the interim builds and everything to do with Lava installs. We're working through what the packages can support, where we are with the various versions, how we can do the deployment, and things like the actual configuration tools and the issues you get as you might come along. Lava is not a simple single package install. It is a lab. You do have to manage it and maintain it. So there are things involved. Oh, why is that? There we go. That's where it should be. So currently, Lava is supporting Debian Jessie, Debian SID. Those are our main installation bases. We can have packages installed on Trusty, Ubuntu Trusty 14.4 LTS. Currently, we've only got capacity to build the 64-bit packages for Trusty. Unicorn is updated directly from Debian using the auto merge. Now, Unicorn is close to release. It's not called 14.10 yet, but it will be when October comes around. So Unicorn is currently one version behind, and it'll stay on the August release. And then once you want to open up the next development release, then that will sync again from Debian Jessie. So with Trusty, you actually have to add the extra app source just for the dependencies that are not present in Trusty. Originally, they were added into Debian and they're in Unicorn. They'll be in future releases from there. It's always useful to install Postgres before you do the Lava install. You can do it all in one go, but just nice to make sure that Postgres is there and working and any other issues are fixed before that. And because we've got this through the normal Debian channels, we've got a full range of architectures. Deployment tool never supported anything except precise AMD 64, but now we've got a much wider range of support, including ARMHF. So I've got boards, Tyler's got boards that are actually running Lava on QB2, QB Truck, Arndale, Utilite Pro, One board. They all happily run Lava server and then control jobs on other boards, or the QB Truck Tyler's got actually runs jobs on itself. So that's all working nicely. AMD 64 and i386, naturally. ARM 64, of course, is the new port coming into Jessie, and yes, Lava server is there in the list that can be installed. There's still a lot of work to do to get ARM 64 up to final release, but it'll be there. As well as that, you've got the other architectures that Linaro and Lava haven't really looked at yet. So we've got things like MIPS and PowerPC, and they're there. Don't know who's actually tried them yet. So the install is a nice little meta package that brings in absolutely everything. If you're doing a nice single instance, just one little machine where you want everything on. If you're doing it in a more controlled way in a lab, then you just pick Lava server. That brings in the server. Then you've got the other daemons that might be needed for the lab, which I'll cover later. There is a little bit of configuration. There's the main step of, is this a master instance or is this a worker for an existing instance? The simple question that DevConf asks. And you get an instance name. Unlike previous deployment tool ones, the instance name now is just a label. It's just a text string. It doesn't affect anything about where the files live, where your data goes, where the log files appear, none of that. There's just a label. It's useful because it helps you find out whether this is your staging instance or your production instance when you're looking at the Lava front page. And the packaging does not go and wipe out your existing Apache config. There is an Apache file. You are free to edit it. It's a normal configuration file. If you want to use it as is, 3 simple commands will put that on as your default Apache virtual host. And then a simple command to give yourself access to the Django admin. Choose the name, pass an email and a password, and you can log in to the administration site and then give yourself the rights you need or any other users you need. Upgrading is now really trivial. It's a case of there's a new package, install it, and it works, and it goes through. These things are constantly tested through the Debian QA tools and CI tools, so these things just work. There's no more worries about how the deployment upgrades. And we do recommend that you install and keep Lava Server and Lava Dispatcher at at the most recent versions. That's the way they're tested. The refactoring may well make this much clearer and much easier to work with because we won't need Lava Server installed everywhere. It's just going to be on the actual database front end. But that's a way yet. So managing the instance, what are you actually trying to do? Well, sometimes you need to start, stop, or restart. The package install will do a restart every time you actually install the package, so it gets freshened. It'll also, if you are using that Apache file, it will restart Apache as well, so that the WASGI front end is picked up. And the configuration files, the paths to all the things you're looking at, standard FHS compliant paths, because this is packaging, this is Debian, this is what Debian requires. No more files under serve lava. They're all where you expect to find them. So with a package installed, we've added a few little helpers. There's a lot of scope here for other people to come in and use these as an example and expand them and do a lot more stuff with them. The add device is a nice little starter. This allows you to add a particular device without having to go through the admin interface. Now, yeah. Add device was added as part of the packaging work. So it'll be in the Lava Server documentation. There is a section there, but I'll give you the link after. There's a section there on installing with helpers or using the helpers. But yeah, if it's not clear as to where it is in the index of the documentation that's installed, then we can fix that. So this is where you start to think about how to actually run the Lava Server within your lab. You're thinking, well, you have certain daemons that only get installed, only need to be installed once per lab. There's a coordinator, which means that you can have multi-node jobs that work across your different workers and your different instances, and that can be installed either once per lab or you can have it per instance. So up to you. PDU daemon, this is where you're automating the power cycling of the development boards. So you'll have a command in your device configuration that says that this particular board is on that PDU and that port of that PDU, and then commands that can reset it. Now you can hack those together yourself if you want to, or there is a PDU daemon which we wrote is in Lava, in Debian. So it supports a range of APC units at the moment. There's ongoing work to extend that. And if there is, if you have another PDU and you have a way of controlling it, then you can come to us and help us add more support. Whereas a simple command line is where's the daemon listening, which PDU, which port, what do you want to do? Yeah. Now, whilst Tyler's setting this up, I'll just cover some of the issues around this, because we are tracking a rolling distribution. Jessie is not released yet, and Stable is always tracking. There you go. So there are times when the needs of the distribution mean that we have to go through and keep up to date with the upstream changes in other packages. So we've currently got Django 1.7 in unstable. So we're using a demo that uses the old Django.
Yeah, so this is just an example of how to do this on Trusty. Essentially what we've done, the steps are listed here, and we can give a pointer afterwards. This is a Lava test shell job, so we actually have Lava installing versions of Lava. More or less we use a pre-seed file to automate the install. If you don't automate the install, sorry, this is what you'll be presented with. So it asks you if this is a single master instance of Lava, and what that means is this is the only Lava server that you're going to be installing. If you were installing remote workers, which is our way of distributing the work across multiple machines, you'd want to select no here, but for the sake of the demo, we'll just select single master. And then here's where you can name your instance. We'll just keep it as default, but this is the name of the instance in which you want to install. And there's only one instance allowed per machine now. We used to have, with the deployment tool, you can do multiple instances. It's too complicated to deal with that in packaging, so we just say you get one instance per install. And then if you have a different port number for your Postgres database, you can select it here, but we'll use the defaults. And then this, again, the name for the instance. And then this is we'll just skip over doing this. This is just a super min appliance. You don't need to deal with it. And so then the install is going to go along here. And then we'll still have to follow a few steps. Like Neil mentioned earlier, the default Apache configuration is not overridden. When we deploy with the deployment tool, it would just assume that it was the only Apache virtual host on the machine and would wipe out your existing virtual host file. So we've got a lot of complaints about that. So it's up to you to inspect the Apache configuration file we provide, and if that's suitable, then you can enable it. Otherwise, you can then modify your existing Apache configuration to have Lava play nice with all the other virtual hosts you may have. This might take a little bit. So there's about 274 megabytes on the x86 install to get Lava installed, and that's all the dependencies and everything like that. While this is installing, we can take a look at this Lava instance. And as we talked about supporting different architectures, it's more or less a dogfooding exercise for me, because I really want to see the ARM ecosystem be useful to us in the Lava Lab, as well as our members and everybody else in the community. So here is a distributed worker setup in this worker table. My Lava master, as you can see here, has been up for 109 days, and the architecture is ARM v7. So I'm actually running a database for my Lava server with 52 devices connected to it on a 2 gig of RAM Cortex A9 ARM server. So it's been working fairly long. You can see the actual x86 servers that I have for KVMs and doing some of the heavier workload have been up more or less about the same time, although we do have one problematic one that needs to be rebooted every once in a while. So this is more or less of a proof of concept that you can actually run a Lava server on an ARM device and have it be useful. And when I say useful, we do a lot of jobs on here. In fact, this is booting all the upstream trees. I can show you an example of that. So if we just search mainline here. So that query was done on an ARM device, returned and served with Apache on an ARM system. So here's the last 100 jobs that ran across architecture. So AR64, x86, and ARM def configs were booting, all on the server. Let's check our install here. Still going. Do you want to hook up and keep going through the presentation?
There we go. Okay, so what we tend to do is to be able to manage a lab where you've got possibly multiple actual database front ends, many workers. So in the Cambridge lab, we've got the staging instance, we've got the production instance. Those have, staging got 2 workers, production's got how many workers now, Dave? 8. So to manage all of those machines, you often need to use some kind of configuration tool. We've been using Salt. There's various arguments as to whether we're going to stick with that one or use another one, but it's probably just as much hassle to change as it was to actually fix this one. And we found that going to packaging meant that a lot of the custom code we needed to hack around what deployment tool was doing went out of the window. So we simplified, well, Matt mainly, simplified the Salt code base with a lot of deletions. The packaging enforces the right dependencies, so you've got the code you need. You don't need to do a lot of extra packages installed. And the TFTP and the NFS, they can be set up during the package install. There are some external tools. We are looking at alternative solutions for these, particularly Lava Android test. We've already got a way of working that inside the KVM for a lot of use cases, not necessarily all. Linaro image tools, the dispatcher refactoring may well have a big impact on how we use that, or if we use it at all, whether we continue to use that to actually manage images on the fly. And all the code that you actually have for Salt is in our Git repo. Matt, do you want to cover anything else on Salt? Or? Yeah. So if you want to use Salt, there are examples there of our configuration. They're not going to work for anybody else without changes. But there are other tools that you can choose if you prefer to use Puppet and what's some of the other ones, Ansible. And yeah, then Lava will be nice and easy to work with that because it is a very simple install to actually manage via the packaging. So Lava goes through standard production releases. We do have hot fixes every once in a while where we have to. The release itself is just Lava Server and Lava Dispatcher. Those will typically get uploaded to Debian, and then they'll be available as packages within a short period of space of time. There are tools, again, documentation inside the Lava Server doc package that allow you to build from your own Git tree and your own set of packages. So if you need to, if you want to make, if you're developing and looking to contribute back upstream, please do. Then you can build with your local changes, install the package, and see how you get on from there. But our own releases, we do release the original tarballs from which the Debian packages are built. If you're using a Debian-based distribution, it doesn't make any sense to use the tarballs as is, but the tarballs are there for those who want to have it on a different distribution. We'd be very interested if anybody has the skills and experience to create packages for other distributions. Lava is generally a month behind Linaro. So Linaro will do a release, and then Lava will actually make a release using the same tag that tends to be the first week of the following month. That gives Linaro the chance to actually get their release through on our stable code before we upgrade it. Right. What do we have in?
So this is just an open discussion. Anybody has their own
so yeah.
stuff on the tool, email or have questions about the
Okay. So who's got their own lab? Who has got Lava installed? Who's having problems with their Lava install? That's indeed. So let's go through some of those issues. What kind of problems have we seen? Is there a microphone for the room? Okay, Paddy.
Okay, I'll start. So there's a lot of assumption about the setup when you install the packages. So it's really tailored for a lab like we have in prod. However, I have just my BuildBone on my laptop. I want to use Lava, and we expect PDU. I don't have PDU, so the scheduler just it tries to put online my board. It doesn't work. So all this thing, it doesn't work for me. Well, yeah. Actually, it doesn't work out of the box. There's a lot of extra step. It's nice to see that add device exists, because I've done like Riku, all the configuration manually for the devices that I have and so on.
Yeah. The Lava will try and issue a software reboot where it can, and if that works, then it can carry on. So I've got a little lab set up where that just does work. It depends on whether whether the image on the board actually does a proper reset, proper reboot. But yes, PDU, we need to get a wider support for PDUs where we can. And it's one of these extra pieces of hardware. Now, we are looking at a server-in-a-box piece of hardware that will have a PDU built in, a network switch built in, a serial console built in, and that will make things a lot easier. That's in the final stages of schematics at the moment. But it's not an official project. It's something that I'm doing with a friend on a volunteer basis. So timing is hard to find sometimes. But yes, that is a definite problem. Lava, from the packages only goes so far. It can only go so far because there is often extra hardware required, whether it's a network switch or a PDU or a UPS. These kinds of things become essential if you're actually doing any real testing with Lava. You need to have other bits of hardware.
But if you're going to do automated testing, you have to have some level of automation, that includes power. If it's a private sort of install and you don't have a PDU, the only option is to make the power off command be echo power off now, please. Echo power on. So you don't. You can't automate something that's not automatable.
Except it's not written anywhere. And I think for a lab, de facto you will have a PDU. For a developer, de facto it doesn't have a PDU. And you need to provide both use cases. And it needs to be addressed in some documentation way or something like that. But
the documentation can be improved.
Yeah, it's an issue. The other thing about documentation, and that's another topic. So I was looking around about how to configure all the devices and so on. So it's not very clear on the inline documentation. So I find a nice wiki page by our friend from Collabora. They have done their own Lava packages at some point. They have nice documentation how to include some devices and their configuration, except it's completely confusing because it's on the Debian wiki, and our packages doesn't work the same way. So please kill this page.
Yeah.
Yeah, give me the link.
Or update it.
Give me the link to the page, and I'll work on the content of it, and I'll fix it up. Yeah. But yes, the second hardest part of working with Lava is getting new devices and added to your instance. I would say if there are devices that Lava has already introduced, then things like add device that'll help with it will be fine. When you've got a device that Lava hasn't seen yet, that's a whole different ballgame.
For the most part, it's actually not that difficult even for a new device type, as long as it comes into a category or a class of devices that we already support.
Yeah.
It's only when it has some completely bonkers way of working that we haven't encountered yet, and that's getting less and less. It really is. Yeah. So, you know, we're now dealing with things like the JTAG reprogramming of the B2120. We're going to be doing the same on APM, that sort of thing. So, but it's really the class of stuff we don't support now is really, really small.
You just need a kernel. You need a working kernel to start you off, as always.
Yeah. Well, yeah, without that.
Well, and you know, that depends on
that ever happens.
Well, and the other thing is we're trying to refactor the device structure in the current dispatcher. Every time we have to make a change to something, to use the new driver model where we have a base class like fastboot that implements, you know, fastboot and ADB, the general functions that the devices need. Then they have a driver class, which are broken down into subclasses, into very small parts, because we have fastboot boards that have a quirk here and there, and we'd rather not have a single class to describe all the quirks. Instead, we separate them down into smaller subclasses. So it's easier if you have a custom board and you need to do a quirk now, you can just inherit from the base class and do your little tricks to make your board move. So that seems to work a little bit better, but not all the classes are there yet. And, you know, I think with the dispatcher refactoring, that's probably the model that we're going to have, is that you implement these chunks and you can override these methods if you need to, but it's inheriting from a base class that works well.
Yeah, I mean, an example of that would be integration of the Juno into Lava. The big task for Juno was actually getting the board up, getting the working kernel and a good rootfs and all that sort of stuff.
Firmware.
Actually writing the don't go there. Writing, but actually, what I did in writing the support for that was inherit effectively off Versatile Express, because it's that close, and then just overriding the one or two little bits that were required.
Riku?
Yeah, so one thing I found confusing is that when you add a device that you have to both edit a file and go to the web interface and click things, and how these things match together. It would be really good if you had either one, either put the file, have everything there, or put it in the web and do everything there.
Yeah, clearly that is something that annoys everybody who works with Lava on a regular basis. It's part of the refactoring. Will get us most of the way to a point where we can have all of the actual device configuration in one place.
Yeah, I mean, that is something that has come up, I think, pretty much every Connect for the last 3 years.
Yeah, it's not a new problem.
It's a slight disconnect.
It's unrelated to the whole.
It is annoying.
Yeah.
But there are good reasons why it's like it is,
yeah.
or how it got to where it is.
Yeah.
And for the future, yeah, you're absolutely right. It would be wonderful if you could do all in one place, one-stop shop. And it's coming.
We're not there yet. Yeah, we're not there yet.
Okay. Any more questions?
Real-time bug report. Maybe it's fixed. So one thing I noticed is that when I installed Lava, it screwed my TFTP setup.
So there's an option to say, do you want the maintainer's version of the TFTP configuration or keep yours? So if you said yes, then it's probably overridden approach.
So maybe
that's something I'm hoping to get some time to actually work on that, because sadly the TFTPD HPA package doesn't have a simple way of either adding another directory to use, or so it just has a single configuration file that and then all you can do is replace it. And you go, it would be really nice if that package had a way of managing that, but sadly it doesn't yet.
I know I have my own script magic doing full on the TFTP dynamically. And
typically with a larger install, that will just be sorted away by Salt. It'll be a case of Salt puts that file there, and that makes sure that things happen that way. But yes, on a small install, your own setup, if you've already got the TFTP set up, it's annoying.
This is another sort of consequence of Lava is designed primarily to run in the Lava lab, or in a lab, in a large configuration where you have a server dedicated to the task. The home use is where, there's the small home use. It's just annoying. But
the home use was never really that easy to do when there was deployment tool. Now that we've got so many more packages, so many more architecture supported, and so many more distributions will be able to carry it, because all Debian derivatives will have these packages available to them if they choose to add them to their filters. So there's a much wider base now. So things like this, we do need to actually keep in mind and keep a balance, so that the home user isn't put on the spot quite so much. Because in the lab, yes, the Lava was designed for the lab, but in the lab we've got all the different tools to make sure that it actually gets deployed the way we want it. Sometimes you actually need to think about...
We deploy effectively on a completely clean server.
Yeah.
We don't have pre-existing TFTP setups or whatever.
I mean, the Apache config was a big step to doing along that road, because we used to actually just obliterate anybody's Apache config and just say, this is ours, this is our server, and everything else just went away. So there are steps along the road like that. It was something that was relatively easy to implement for Apache. It's harder for the TFTP. We just need to work on that package.
Any more?
The other thing is, for the demo it works fine. It's controlled in the environment. There's one interface and stuff like that. And sometimes the deb configuration try to be smart. And in my use case, I had a lot of interfaces, even virtual interfaces like Docker or whatever. And the dispatcher try to be smart for that, and pick up one interface which is just the wrong one, and it didn't work out of the box.
Right. So if we go back. So the dispatcher configuration does have options. Again, please come back to us and remind us to make sure the documentation covers it properly. But there are options in the dispatcher configuration that allow you to list only the interfaces that Lava should try and use for its routing between the device and the master. So that allows you, when the job starts, for example, if it's on my laptop here for my local host, it'll have WLAN 0 in that list. And so therefore, when the job starts, it uses whichever interface first gives it a route to a route that's actually going to work from the device to the dispatcher. And then they say, right, that's the IP address that I use to communicate, and that's the route I use, and that's the interface I use. So there is a list in that configuration file, and you can, if you remove an interface from that, Lava will just simply not try to use that for routing. But yeah, a bug report on that for documentation would be useful.
Any other question, comment, feedback? Yeah, one last comment. I see OpenEmbedded. I think Kuhn has OpenEmbedded recipe and is having Lava running on Angstrom.
Right.
It exists for OpenEmbedded.
That's good. I would love to see the scripting for the database setup and that kind of stuff for these kinds of distributions, and we can because that's all the Debian packaging is doing now, is just setting up the database and then doing some permissions on some of the files that we use as a mount point for the SSHFS. The vast majority of the work that had to be done previously is now, the majority of it's gone away simply because we're using standard paths, and the rest of it is actually just managed by the packages we're using as dependencies. So the actual process of installing Lava from the tarball is a lot easier than it ever was before. We never used to be able to even release tarballs. It always had to be directly from Git. So that in itself is a major step forward. Okay, thank you very much.
We're actually not starting the next session for a while. I'm just getting set up in advance.